Today's lesson is on how to subtract expressions. Subtract 0.95x minus 0.4 minus negative 0.99x minus 0.13. Take a second to copy down the question. So now, subtracting these expressions is the same as adding them. There's an imaginary 1 here, so I'm going to distribute that 1 to both terms inside the parentheses. I end up with 0.95x minus minus 0.4. Now there's also an imaginary 1 here, but it's negative, so I'm going to distribute this negative. Negative 1 times 0.99x is negative 0.99x. Negative 1 times negative 0.13 is a positive 0.13. Now that I got rid of my parentheses, I'm just going to look for and combine like terms. I have 0.95x and negative 0.99x. So when I combine those, 0.95 minus 0.99 is equal to negative 0.04x. So now I combine those like terms. Now I have negative 0.4 and a positive 0.13. So when I combine those, I end up with a positive 0.09. And now I have no other like terms, so this would be my final answer. The second question, subtract 17 plus 4.5m plus 8k minus 7.5m minus 9 plus 4k. Take a second to copy down the question. So this is the same process. I need to get rid of my parentheses. I have an imaginary 1 here, so I can distribute that 1 to everything inside. I end up with 17 plus 4.5m plus 8k. Now I have the same thing. There's a negative 1 here, an imaginary 1. I'm going to distribute that negative 1. Negative 1 times positive 7.5m is negative 7.5m. Negative 1 times negative 9 is a positive 9. Negative 1 times a positive 4k is a negative 4k. Now I just have to look for my like terms. 17 and plus 9. 17 plus 9 is equal to 26. So I combine those. Positive 4.5m and negative 7.5m. When I combine those, I get a negative 3m. So I use those. Plus 8k minus 4k. When I combine those, I get a positive 4k. And now, since there are no other like terms, this would be my final answer. And the last question. A frame holds a picture that is 15 inches long and 3 inches wide. The frame border is 3 inches around the picture. What expression represents the area of the frame border? Take a second to copy down the question. I'm going to start this problem to make it a little easier. I'm going to draw myself a picture of what's happening in this situation. So I'm going to start by drawing my picture. So my picture, here's my picture. It is 15 inches long, so that's 15, and x inches wide. If I put them the other way, it would be okay. This would also be a 15, and this would also be an x. Now, the frame border is 3 inches around the picture. So this would be 3 inches. This would be 3 inches. This would be 3 inches. And this would be 3 inches. So this new blue line, that represents my picture frame with the border. So now I need to determine the dimensions of that blue picture frame. On the side here, this part, this part is equal to x, this is 3, and this is 3. So this part would be 3 plus x plus 3. Or I can combine these like terms and make this 6 plus x. Now on the other side, this is 15, this is 3, and this is also 3. So this can be 3 plus 15 plus 3, or 21. So now I need to find the area of the frame. So the area of the frame means I am looking for this part, the shaded in part all around. I'm looking for this whole area, this purple part. If I wanted to find the area of that purple part, I can find the area of the bigger frame. So the area of the frame, which is the bigger part, the bigger area, so that could be 21 times 6 plus x. I can distribute here and get 21 times 6, which is equal to 126, plus 21x. Now I can find the area of the picture. The area of the picture would just be 15 times x, or just 15x. So if I wanted to find the area of the border, I would do the area of the frame, which is 126 plus 21x, and I would subtract 15x. Now it's just subtracting. I have an imaginary 1 here, so when I distribute, I get 126 plus 21x, a negative 1 here. When I distribute that, that becomes minus 15x. Now I can just combine my like terms. Positive 21x minus 15x gives me 126 plus 6x. So this would be my final area of the border. So I know that problem may have been confusing. We will discuss it more in class tomorrow.